Okay, hello. My name is Akeem Vivens, and the experiment I'm going to be doing is based on velocity, time, and distance. And as you can see right here, yes, as you can see right here, I have my formulas. This formula right here is based on how fast the car is going when it comes down the ramp. Because when you go down the ramp on the highway, you don't always just slow down. You know what I'm saying? You need so you're not going to be able to slow down the time. But this is the car slowing down. This is the car speeding up. And as you can see these dots, you can see that the car is speeding up because the dots, as they get more and more further, and they spread apart, so the car is going faster. And so right now I'm going to explain to you velocity. Okay, velocity is the rate of speed going in one direction. Another experiment, unlike this one, if the car were turned in a 180 degree angle coming down the ramp, it would give velocity a negative formula by causing motion of the car rate to slow down in a straight line involving inertia. So when I mean to say slow down involving inertia is based on like distance and speed in one. And when I mean they slow down, I'm saying you don't always go your further distance. Some people may stop before the stoplight, and some people may stop after the stoplight. And what inertia is, distance and speed, like I just said. And so, like I said, you don't always slow down. And then time is a measured or measurable period of time, and this is the prime of this experiment to see how fast or how slow it would take a car to reach its destination. And as you can see, you can't see, but hold on, let me move it up a second. As you can see my graph right here, well, not graph, but my time and velocity based on the car I have. I used a Hot Wheels car. Okay, and my time was 1.25, and in 1.25 seconds, the velocity was already at 0.411. You see what I'm saying? Making the inertia speed, giving it more speed and more distance. Then, as you can see, as it was speeding up, got to 1.30. But velocity is not always going to add up with time, as you can see that, because my velocity is 0.847. And you see that your distance speed might be more. You know what I'm saying? They're not always going to be the same, so they're going at each other. And then on my next one, I had 1.35. The velocity was 1.137. Giving velocity maybe trying to have it with time, but I want to say not necessarily, because it's a little over. Like I said, your time and velocity is not always be the same. Then distance is based on how far the car has traveled. For example, the car that I used, like I said, the car traveled 163 meters. Yeah, the car traveled 103 meters. That's the size of 240 meter rulers. So that was pretty good for a Hot Wheel car. Now the second car I tested, I didn't really want to put in here because it was kind of slow and it had more weight. But to add to this experiment, also inertia involves the weight and the compact, but the weight of the car. Because see, like, for example, if you take a NASCAR and an 18-wheeler, they're not going to be at the same inertia, but might have one more speed than that, because the NASCAR is lighter, but the 18-wheeler, it has more weight, but it's slow because it has more weight. Not to mention that it's carrying cargo. So that's why you might want to look at that. So so my experiment, like I said, it was based on velocity, time, and distance. And my name is Akeem Vivens, and that was my experience. I hope you liked it, and I hope that you're on formula, inertia, distance, time, and velocity. Thank you.